Thank you. Thank you, thank you. We're a little bit behind schedule as per usual, so I will move fast. Hi, everybody. It's great to see you. Thanks for coming out to CityJS London. And I look forward to seeing you at other CityJS events. For those who don't know me, my name is Tejas. That's pronounced like contagious. And I guess in England, it's pronounced like contagious, isn't it? Are we doing this in British then? Anyway, I've been building on the web for over 20 years at this point at various companies, either as a consultant or as an employee, and I love the web. I've been doing it since I was a kid, not child labor as a hobby, and then I got a job. And I absolutely love it. And today I'm here to talk to you about event sourcing, but for JavaScript developers. Event sourcing. And the reason I'm doing this, there's many, many different motivations that I want to go into before giving you this talk. But maybe we can get started with a quick show of hands. How many of you are using event-sourced architecture? Yeah, like 2 hands. And that's why I'm doing this talk. I feel like many of us in the JavaScript world are not exposed to it. And I feel like once we are, we get a tool in our arsenal that we can use at the right time in the right place. Of course, we can't use it if we don't know what it is or the details of it, right? So that's the point. In these 30 minutes, I want to give you just a primer on this is the thing, this is what it's good for, this is where it's not, and just enable you to make your own decisions, because knowledge at some level is power, right? It's not absolute power, but here we are, okay? So I want to walk you through why I'm doing this, and I want to do that through the lens of a use case. I was the head of engineering at a company a long time ago, a very long time ago, called G2I. Anyone heard of G2I? Probably not. Okay, this is Daniel. Daniel has heard of everything. Daniel Rowe, maintainer of Nuxt, and great human being. G2I is a staff augmentation company, and how it works is they match developers with companies, and they vet both sides. So like Uber will go to G2I and say, hey, we need 3 engineers who know React and TypeScript for 6 months. And then they already have like a pool of like hundreds of engineers that they've vetted and they know, okay, these people will be good at Uber. And so they say, hey, Uber, these are the people, that's what it's going to cost, and they make that match. And they've vetted Uber to make sure they're going to treat these people well, and they've vetted the people to make sure they're going to treat Uber well. It's really great, bi-directional. And if you want to join them, then you can just sign up and be one of their developers in their pool and get cool projects, okay? This is not a pitch for them. I was working there, and as part of that application process, we needed an event-sourced system. And you might be thinking, okay, but like why? And I will explain that to you. It's people apply, and as part of the application process, there's a piece where there's a code review. So they submit a code challenge, a simple React challenge. And a big drain on the company's time was we had to have people sit and review the code. And then it took some time to get back to people because maybe it took too long to review this code in detail. So I was tasked with building an AI system. This is not like machine learning AI. This is rule-based AI, but it's AI all the same. The rules are just manual. I had to code them. And the rules are basically, given a React project, how close does this follow the React docs and certain React best practices? For example, are you forgetting the second argument to use effect and causing like infinite loops, for example, right? So I built a system that will read the code and give them a grade for various criteria in what is called a rubric, okay? This obviously needs to be human verified, but the goal is it makes things faster. This needs to be event-sourced because with most AI-based systems, somewhere you can have false positives. And it would be super helpful to know where in time did the grade go wrong. Okay? And that's really what event sourcing is. It helps you track down issues through time. Okay? Let's talk about what event sourcing even is. And I want to start with a distinction that event sourcing is event sourcing and not event-driven architecture. We think of event-driven architecture like signals. A great talk by my friend Attila just in a few minutes. Signals are an event-driven primitive. An event happens and state updates. This is also how React works. You set state and something happens. That's event-driven. Event sourcing is you have a bunch of events and that's all you have. You have an event that somebody created a thing, updated a thing, delete. You just have a big list of things that happened. And then your state of your application is derived based on these events. Is that clear? Is that tracking? So instead of querying a database, hey, what is the state? What is the list of products? And you do a select statement. Instead of doing that, you go like, okay, let's look at every event. Okay, so a product was created, a product was edited, a product was deleted, another product. You just look at a long list of events and go like, okay, based on all of what happened, I derived the state today. Is that clear? This is really the gist of event sourcing. So event sourcing answers the question, how did we get to the current state, and what is the current state as a consequence of the events, as opposed to just what is the current state, right? Instead of like, get me the products, show me what we did over time, and I will derive the products. That's the distinction. And in many ways, this is very close to the human experience. As human beings, we're all here as a consequence of the events that happen to us. And some events are acute. How did you sleep last night? Did you have coffee this morning? And other events are chronic. You maybe had something in your childhood that affects you today. We are the product of events, and our state is sourced from the events. That is event sourcing, but with software. It's exactly that. No human being is like, my state is this now because it is this now. Right? And as a result, you can draw on your experiences and make informed decisions. So is the case with event sourcing and software. Let's talk about what events are. Events come from a paradigm, a school of thought called DDD. This is not TDD, but it is something-driven something. DDD is domain-driven design. Anyone familiar with domain-driven design? Yeah, great. It actually comes from, I didn't invent this, it comes from a book by the great Eric Evans. And it talks about building software in a way that is specific to the domain that the software is in. So, for example, we don't do a select statement, we get products. You see the difference? If we're an e-commerce store, we don't insert a record, we add a product. We reason in the domain of our thing. Is that clear? So it's modeling software in the realm of the domain and not just at the level of software. It's reasoning about things at a level of abstraction that is specific to the class of problem you're trying to solve, okay? So with that, events are temporal things that happen in the specific domain. So an event could be, I added an item to the shopping cart. That's in the domain of a store. It's not I inserted a record into this database, into this table. This is just a bare minimum event. You have an ID, that's hopefully unique, unique per type of event. You have when the event happened, and you have some metadata. So I created this event. Ideally, events are self-contained, meaning they're very verbose, and they don't have like external dependencies. So an event shouldn't have a reference to like some other event. Then your system is probably going to crash because at some point you maybe need to remove events, you need to rebase, et cetera, et cetera. Okay? This is what a typical event looks like. In some cases, you will have a correlation ID on events where you can really map behavior in a transaction. For example, the add to cart could have a correlation ID in common with the pay event, with the checkout event, with the browse event. And then you could see like, okay, all these events happen for this one outcome. And it's a really great way to model behavior through your application. You can also have a causation ID, such that the buy event is linked to another event. So this caused that, just like we do in our everyday life as human beings, okay? But let's look at some real-world examples of event-sourced systems. If I ask you to think of one, can you? Spoiler alert, we use an event-sourced system almost every day, if not every day in our work. Can you think of what it is? Git, exactly. Git is like the gold standard of event sourcing. And this is really, if you take nothing else from the talk, if you're thinking about an event-sourced system, the question to keep going back to is, okay, how does Git do it? For example, events are a lot, and you need sometimes to access a state very quickly. How does Git do it? Git uses a technique called snapshotting. Okay, let's learn from Git. How does Git intelligently direct you to the right event? It uses a data structure called a Merkle tree. Okay, let's learn from. That's the way. Some would say Redux is an event-sourced system, and it can be if you're intelligent about how you store your events and how you derive your state. Redux sort of toes the line, right, between event-driven and event-sourced, so I wouldn't go fully, but I'd invite you to think, okay, what else is event-sourced? What else can I learn from? Because the truth is, it enables a lot of very, very powerful use cases. Use cases around business intelligence, as we talked about. Okay, so a user goes through this journey, and then they convert at this time. And you can change an event and watch the course of your application change. It also enables use cases around chaos engineering. Anyone familiar with chaos engineering? Since you derive the state based on events, you can always replay a subset of events, but like change one event in the middle and see how the rest of the system reacts. It's really powerful, especially when combined with machine learning and best pathways. So you could say, okay, what if we change the price? Predict now how many people will buy this based on your history of events. And you can combine this with generative AI to really model some really great scenarios. You can time travel debug. You can literally go like, where did something break? I want to go back in time, identify it, and fix it. You could do a number of things. I hope I'm making the case for this, but it's at the point in my presentation where I'm tired of listening to my own voice. And so let me just show you. I built a very simple event source system to sort of, what I want to do is contrast the traditional way we reason about software with the event-sourced way, okay? And it's a contrived example, but I hope I show you the mechanism so you can export a protocol to use in your everyday work for where it may make sense. So let me do that. There's no timer here, so this conference is already over time, and because I can't see how long I'm going, sorry.
Clock there.
What?
On your screen.
What time am I supposed to finish?
I don't.
Yeah, nobody knows. Great.
I'm very good at my job.
All right, so let's take a look at this demo. So this is my very, very, very contrived example. We have a to-do list. Now, if I ask you to think about how you would implement this, let's walk through this in a traditional sense, right? We have an input, so we'll add one. What are we doing here? So I do this, and I click create. What's going to happen? Insert into to-dos values. You're thinking in SQL, so I'm inserting state into a database. OK, and now if I load this, I'm select to-dos from, right? That's how we think. Let's do it again, and again, and again. And so what we're doing is we're just inserting records into I think this mental model works for you. This is not traditionally architected. This is an event-sourced to-do list. And so I want to explore the nuance there, because I feel like we all are familiar with the traditional way. Let's look at how this looks in event-sourced. Let's look at the code here. So I'm going to move this to the side. We'll open VS Code. And what do we have? So this is built with Astro, by the way. For those of you who don't use Astro, the single best way to build websites in 2024, period, no question. OK, where's Elian? If he's drinking beer, isn't he? OK, so let's look at the code. So we have to do. What are we doing here? So we get events, and I want you to pay attention. We're literally just getting events from a file called events. We'll look at what that is. But it's very similar. So we have the to-do list. We map over it and do LIs, just like this. To create a to-do, let's look at that. So we have this form somewhere. Yeah, here, form. And the action is to-do API create to-do. So what does it look like to create a to-do? Well, let's open that file and see. This is what we're doing. And thank you, Mateo, for that great Node.js talk, because this is some Node.js here. Here's what we're doing. We're looking up this JSON file. If it doesn't exist, we create it, right? And then we get an ID based on the next line in the file. So we generate like a sequential ID here. We create an event. And this is the cool thing with event sourcing. It's strongly typed. So you could be like, these are the things I can do. Beautiful, OK? And then we just append it. That's all we do. We just append. We have our store of events is an append-only log. You just like keep adding events to the bottom of it. So I just made like 5 events. Never gonna give you up. So let's look at what this event store looks like. And this is very rudimentary because I want you to understand the mechanism. If I go to my events file, that's it. That's how we're constructing the to-do list. We just write to this. And why is it fast? It's fast because we don't have to iterate through a list. We just get the latest state. We go line by line. It's an append-only log. So this directly relates to this. Now watch this. If I do a to-do item, boom, boom. If I delete this, boom. You see that? That's it. My state is derived from all the events. This is event sourcing, basically. Now, how are we actually deriving the state? Let's look at that. We have this file, events.json. And JSON-L, by the way, means JSON, and you can have new lines. It's append-only. We have some stuff here. We don't need to do that. Eventually, we have this function called list to-dos, and we give it our events. And list to-dos derives the state based on events. Let's look at the implementation of this function. So we have an empty array. We iterate over every event since the beginning of time. And for create to-dos, we push the to-do into this list. To delete a to-do, we filter on the existing list and just remove it. To do a to-do, we find the to-do with the ID from the event, and we mark it as is done. And it's a very basic switch case that just derives state from events. This is, in its most basic sense, event sourcing. Clear? Great. So you might be thinking, OK, but like, why all this? Why not just like a SQL query and we're done? And that's because this system, one, I just know everything that happens. And two, it unlocks some really great possibilities. Like if we go to like debug mode here, this is everything that ever happened in the application since the beginning of time. And I can go back to this state this state, this state. I can see, okay, we did to do 4, and I can really like time travel debug. I can also, at this point in time, so before I added up, I can intercept this and do something else and fundamentally change the evolution of the system. I could play events only up to here, and maybe some malicious person hacked me. I could just get rid of that set of events and start fresh from here. I could do so many different things. In fact, let's go back in time and change an event. So let's, instead of never going to give you up, I'll say never going to let. I just created different events. I'm rewriting history. And there we go. So you see that? Incredible. So that's the power of event sourcing. And it enables a number of use cases that we've already talked about. She just told me I have 3 minutes. 4, wow, thanks. And so let's go really quickly through the rest of this. That was cool as a contrived little demo, but what does this look like in production? You see, event sourcing tends to bias a system more towards being write-heavy, because you're writing events to a log. Most systems are read-heavy. You go on Twitter, you doom scroll, you're just reading, reading, reading. You often write less than you read. With event sourcing, most things are writes. So you need to consider something called CQRS. That's Command Query Responsibility Segregation. And it's a big technical term. It just means like separating your reads from your writes and arguably using different stores for them. Okay? And this is where you use a tool like Kafka. What is Kafka? It's a queuing system that receives events, stores them temporarily, and allows consumers to consume them in order without dropping them. The worst thing in an event source system is you drop events or you get events out of order. And Kafka is a great queue that ensures in order. In fact, I have a little demo. This is not mine. I didn't write this. This is from Software Mill. But this is how Kafka works. So you have a producer here producing events, and you have 2 nodes that these things just store events, and a consumer that often always consumes them in the right order. And you can heavily parallelize this. You can have like hundreds of different servers, and you can really handle events at scale rapidly. This is why Kafka often goes with event sourcing, because it's something that handles writes very, very well and is extremely performant. Okay? Let's talk about, how do I go back to my presentation here? There we go. Let's talk about where to store events, because they're just JSON, and it gets to be a lot. So you could store them in any traditional JSON store. Event store is a specialized one, but you could use something schemaless like DataStax. Or I actually think the best way is RAM. You can store a lot of things in RAM. There's a website called yourdatafitsinram.net. And let's see, does my data fit in RAM? Let's do like okay, well, it spoiled it. But I could go 1,000 GB. I could even go like petabytes. Probably not. But at some level, let's maybe 1. Okay, there's never petabytes, but terabytes. Let's see how far we can go. Imagine storing this many events in memory. That's So yeah, you could get like 64 terabytes. You could get that many events, and obviously you need some for your other system stuff, but 60 terabytes is a lot. And so at scale, the way it's worked well for me is I store most immediate events in RAM, and then offload past events as snapshots. We don't have time, unfortunately, to get into this, but I'll breeze through it. You can store snapshots in any relational store, and a snapshot is a derivation of state, and then you replay new events on top of the snapshot. This is exactly how Git does it as well. Okay? Finally, the biggest common problem is rebasing. So if somebody does an event and it contains a password unencrypted, oh no, we need to rewrite history. How do you solve that? What's the golden advice for the event sourcing? How does Git do it? How many of you have committed a password at some point into your Git repo? What's the solution? Yeah, look, Git rebase. That, but for your event sourced system. This will obviously take months of effort. It's not easy, and then you have to have a one-on-one with your people and go we don't do this again, and so on, because it's very expensive, but it's possible, and it's the biggest problem. Okay, should I use event sourcing for everything? What's the engineering answer? Let me hear it. It depends. For my AI code grader thing, it was very important to know where did it go off the rails and give someone a wrong score. It's when you have a use case like that, event sourcing oftentimes is really great to be able to look at where did it break and to simulate future scenarios. So it depends. And my goal here is to give you this tool in your arsenal to find the right, when the time is right, you'll know it, and you'll be like, wait, let's use it. And I hope I've given you that, okay? Because the beginning, I asked who heard of event sourcing, like 2 hands went up. So let's wrap up. We covered a lot of content today. There's actually a lot more, but we talked about event sourcing. We talked about domain-driven design, what an event is, where to store the events. We even looked at a little demo. We didn't discuss a number of different things. For example, why is Kafka so fast? How is Kafka so fast? How does this compare to like something like Postgres' write-ahead log? How does optimistic locking play into this? There's a lot more we can discuss, and a lot more that we do discuss in my podcast, which is very, very, very long form, very detailed. Episodes are like 2 hours, and not everybody's into that, but if you are, I'd invite you to have a look. You can also, if you're not interested in the whole 2 hours, with AI, you can like search for like the thing you want, and it will search across every guest, every conversation, and give you the answer you hopefully deserve. With that, I want to thank you so much for your time, and it's an absolute honor to be here.